Permutations and combinations are two of the tools that we have for counting problems. So how many ways can you get from the start to the end of this grid by only going up or right? So you could go right, then up, then right, then up, or you could go all the way right, all the way up. There are a bunch of different paths that you can take. And by the end of this lesson, you should be able to figure out this without listing them all out. So this class of counting problems has three types: complete orderings, so red, then yellow, then green, then blue, then purple; partial orderings, where we have red, then yellow, and these are all, we don't care about the order of them; and then groupings, when we're grouping these two together and these three together. Complete orderings is given by a list of n items, where we do the number of items times one fewer times one fewer than that, all the way down to 1. This is abbreviated n factorial with an exclamation point or a bang there. So that's part of the notation. So 3 factorial, if I had 3 objects, like ABC, I can list them ABC, ACB, BAC, BCA, CAB, or CBA. Those are the 6 different ways we can list them. And we can do this by saying there are 3 options for the first letter, and once we've chosen that letter, we only have 2 options for the second, and then 1 for the third. That 3 factorial is 6, the number of ways. Now, if we wanted to do with 7 items, we would do 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 5,040. You definitely don't want to list out 5,040 different ways of ordering 7 objects. So how would you reorder the letters in the name Saver? Well, because it's reordering all of them, we're going to say that it's going to be a factorial. And because my name has 5 letters in it, we're going to say that this is 5 factorial. So that is how many. And then when we do 5 factorial is 120. All right, in how many different orders can 12 Olympic swimmers finish a race? So, because we're looking at all of them, we would say there are 12, and 12 factorial is how we're going to calculate this. 12 factorial is 479,001,600. There are millions of different ways that you could just reorder 12 things. You can imagine how big this becomes. And this is because what the calculator is doing is 12 times 11 times 10 times 9 times 8, all the way down to times 2 times 1. So, complete orderings we do with factorials. That's what we've done so far. But if we want to just look at part of the set, if we just want to order 2 things or group them, we use permutations and combinations. So permutations, partial orderings are given by permutations. If you choose 2 items, so R would be 2 here, and N would be 5 here. There are 5 objects and we're choosing 2 of them and ordering those 2. So this is pronounced NPR is n factorial over n minus r factorial. So 5 factorial, 5 minus 2 factorial is 3 factorial, and that's called a permutation. Permutations, we care about the order. So 5p2 is 5 factorial over 3 factorial, which is 20. There are 20 different ways to do this. And one of the other ways of looking at this is saying, okay, well, you have 5 choices for the first item. Now that you've used that, there are 4 choices for the second item. And we don't care about the other 3. We don't care about them at all. So we just do 5 times 4, and that will give us the 20. But as these get harder, you can still use permutations. And then for groupings, the number of ways of grouping R out of n items is given by n choose R, or NCR, which is n factorial over r factorial times n minus r factorial. This is called the combination. So here we have n is 5, r is 2, and n minus r is 3. So what you're seeing is 5 factorial over 2 factorial and 3 factorial. We're dividing by, we don't care about the order of these two, we don't care about the order of those three, so we're dividing by each of those. This is called a combination, and this is when all of them are grouped together, not ordered in any way. So how many ways can you select 3 class representatives? Let's say the class has 20 students. Then because we're selecting 3 class representatives, we can say that we're choosing from 20 students, we're choosing 3. And because we're choosing 3, and we don't care about who's the first representative, who's the second representative, who's the third, that's why we're going to use combinations. So 20 choose 3 will give us 1,140. Now let's say that let's say 8 are female. If 8 are female, then the chance of choosing three female ones is taking 3 out of the 8. So 3 out of those 8 will be 56. So the probability of picking 3 female class representatives is 56 divided by 1, not cooperating with me, divided by 1140. How many ways can school award first, second, and third prize at a talent show with 20 participants? So first, second, and third, we are now partially ordering them because we care about first, second, and third. This is a permutation. So we're choosing 3. Out of 20, we're choosing 3. So the permutations, 20, choosing 3 of those and ordering them, there are 6,840. How many ways can you reorder the letters in the word mathematics? Well, if we were just doing a complete ordering, we would use a factorial, and that's how we're going to start this problem. There are, let's see, 4, 8, 11 letters. And now we need to divide. And the reason we need to divide is because there is some grouping going on here. For each of the groups, we've divided by those factorials. And that's because we don't care about the order of those things. So we have M's that repeat. We have A's that repeat. And we have T's that repeat. So for each of those, I'm going to put 2 factorial because there are 2 T's, 2 A's, and 2 M's. So I'm going to write this out as 11 factorial divided by 2 factorial times 2 factorial times 2 factorial. This is going to give us 4,989,600 ways. All right, now I'm going to connect this back to old types of problems. There were 4 different sizes of pizza and 7 toppings. Well, we're making 2 choices. This is not any orderings at all, or grouping. So we're making 4 choices for the sizes, 7 choices for the toppings. This gives us, 4 times 7 gives us a total of 28. Now let's say we're making 2 topping pizzas. So we're still going to multiply by 4. But for the 2 topping pizzas, we're choosing 2 of those toppings out of 7 toppings. We're choosing 2 of them. Do we care about the first topping for the second topping? No. So I'm going to write this as 4 times 7 combinations of 2. So 7 combinations of 2. So 7 combinations of 2, and then times 4 gives us 84 is the number of different 2 topping pizzas. Now let's say we're choosing 4 different sizes of pizza, 7 toppings, Coke, and Sprite. How many ways can you select 3 toppings for pizza and get 4 drinks get drinks for 4 people. So there's 4 choices for the sizes of pizza. For the toppings, we are making 3 choices out of the 7. And lastly, for the drinks, we have 2 choices for each person. 2 times 2 times 2 times 2. So there are this many options. That's a lot. So this might take a little while to type in. So this is going to give me 2,240 different options. That's a lot. So counting problems have 3 types. Complete orderings are factorials, partial orderings are permutations, and groupings are combinations. Factorials tend to be the largest, and then permutations and combinations. Thank you.